Good morning. This video is going back to the report. After the previous video, we spoke a little bit about the codes. In this video, we'll be covering the chapter 5, which is data pre-processing chapter. Data pre-processing consists of the steps, all the steps before the mining. So we call them like pre-mining steps. This section, as you can see in front of you in the report, section 5, it has got the pre-processing steps that I have divided into 5 different steps, like steps 1, 2, 3, 4, and so on and so forth. Basically, the purpose of doing that is that there is no specific route or a sequence in which the data pre-processing or in fact entire data mining process works, although there is a KDD process that stipulates that structures the flow of the data and the steps that are carried out on the data till the knowledge discovery. But it's as we have already mentioned it before, that it's a extremely iterative process. Whilst taking you through the pre-processing part, you will realize how much iterations are required to be done. It will become clear that the back and forth going from the data into the transformation and loading and coming back again for extraction is the nature of the data mining subject. Um, so once we have recovered 140,000 timestamps data records of the stocks and the gold price and the currency price and all the data that was crawled from the website, if you remember, I had also mentioned in my previous video that we had collected some static data files from the Malaysian Department of Statistics regarding the overseas trade in billions, population distribution, construction industry statistics, consumer price index, because all these things somehow they have a link that human cognition cannot recognize with the stock market, because it's an integral part of the economy. So we wanted to integrate these static data together with the time series data in some shape or form to see if it can add value. What we realize is that the data is so thin, low density as compared to 140,000 timestamps that numerically or computationally it is very difficult to integrate these two parts together in any sensible form that can add value in the knowledge discovery. So we decided to that for the time being, we just drop this data. Although we have gone ahead and collected it, at least gives us a better understanding of the problem statement that we defined earlier. So here we drop all the static data files. We concentrate on the 6 stocks and the time series of the 6 stocks, gold price and the currency exchange price, and try to integrate them together and reap the best value from the data mining exercise. Basically, all that we are going to do needs to be aligned back to the hypothesis evaluation and the hypothesis that we have set forth at the beginning of this report. In the pre-processing step 2, so that was the dropping of the data and selection of the collected data was done in step 1. Step 2, we try to test the loading part of the ETL process. We wanted to do that to understand the protocol compatibility issues, because we have all the CSV files and Excel files. We wanted to know whether the SAS Enterprise Miner tool, which is going to do the core data mining process, whether it would be in a position to easily accept, ingest the data and allow us to do whatever we want to do inside the miner. Whilst doing that, The miner, SAS miner, will also allow us to explore the data further and try to look at it from different perspective. You see, like if you just look at the bland data frame, it looks different. But when you look at it through some statistical tool like SAS, it tells you a lot more about the data even before entering into the modeling phase. So quickly moving on, we used the integrated data frame mrg underscore dot CSV, and with the help of SAS Studio converted into the SAS table format, which is the SAS 7B DAT. And once we loaded it in, we realized that there are just too many missing values, non-values. The integration is a problem. The time series has got jumbled up because the way how the crawler has crawled it, it's not filtered or grouped together with a stock, but they just come randomly in different lines. So you can imagine 140,000 lines of time series of different stock coming randomly. So all these things need to be taken care of. So we have to unload the data, which was then the step 3. So we came back to again extract transform part after testing the loading. The good news was the loading was perfect. There was no trouble, no hurdles. So we are sure that next time when we come, the SAS Enterprise Miner would be able to absorb the data very easily. So that was the good news. Step 3, we have tried to restructure and the representation of the data in order to group them so that some kind of a meaningful exploratory analysis can be done before we move into the actual data mining process. So we did the filtering of the rows, which ensured that we combine all these things together nicely. Then there were certain missing values in the form of the not a number NaN that were being induced because of the timestamps. Some places the timestamps were there, some places the timestamps were not there. But just because now we have already organized them in a form of rows and columns, we don't need the time anymore because it is mimicked by the rows and the row identifier indices. So we dropped the time, so that got rid of all the unwanted nans that were coming because of that. Then we had 17 nan values because of the time series is not of equal length, and those nan values were getting coerced everywhere in the data frame in all the columns for 6 different stocks. So we have to get rid of them, just because they were 17 out of 2,400 rows, which makes 1% of the entire data set. Instead of imputing, which is not a good idea to do when it comes to time series, because time series is a high frequency random data generated by the actual events happening. Imputing it with any kind of a statistical measure would bring in distortions in that particular time window. So we chose not to do it. Instead, we decided that 17 is very 1% of the total data loss, which means negligible information loss in terms of data mining. So we just drop them and we get rid of that. And then same thing happened that 2000 nuns were being coerced because the gold price and the currency exchange price did not have the same frequency as the stock. So if we have to go forward with any kind of meaningful analysis, we need to, it's good to have more data, is always good for data mining, but if it does not get represented properly, it is going to create distortion and noise in the data. So we decided to, from merging gold price and currency exchange, we decided to demerge and remove it from the original data frame mrg underscore dat, so that we reduce the noise that is coming and the non-values, because there was no way how we could match the gold price frequency timestamps, currency exchange frequency timestamps with the stock market timestamps. There are different ways of doing it, which is not part of this assignment. So we decided that in order to get a good quality, good representation, transform data frame to do a good quality data mining, we will need to demerge the gold price. That's what we did. After we did that, we moved on to step 4, which was loading it back and trying to see how the data looks like. So what we did was we used the same technique as using the SAS Studio. Here is the small snippet of the code, how it was done. We convert basically using the SAS Studio into SAS 7BDAT format, and we load it, and we then go ahead and perform some kind of exploratory summary analysis, as you can see over here using the Stat Explorer. Try to get the feel of the data. So in the first section, you can see it's we just look at top 2000 rows, and then we try to use the filters to select the random selection of 20,000 rows to give this the summary which is more representative. And that's all for this video. Next videos we will be touching upon the codes again. So it will be alternating video series of codes and reports to give a good feel of the data mining concept. Thank you very much.